Hello everyone, I wish you a happy, healthy, prosperous New Year 2024. So today I am going to discuss about plotting of structural data. How to plot strike dip symbol or joint symbol or any structural data on map, because it is often observed that most of the times that size of the symbol plotted on the map is not at all representative of that particular location or particular small area within that map. So I would like to discuss about a standard procedure so that structural data have some meaning and its interpretation will be accurately implied in that particular location within the map. In statistical term, a sample represents a subset of a population. So when we say 33% is a sample, it means we are referring to a portion that represents 1/3 of the whole. So sampling is a common practice in statistics to draw conclusions about population based on smaller manageable subset. So data, structural data interpretation or plotting also must be based on statistical concepts. Now the question is how to collect structural data and represent it in any standard geological map. To acquire lithostructural data, we need to roam systematically as per the objective and the scale of mapping. Firstly, information on the rock types are to be gathered. For sedimentary terrain, across strike traverses usually give optimum information. We need to fix traverse spacing, and as per the scale of map, in case of igneous or metamorphic terrain also, observation need to be arranged along traverses perpendicular to the strike of major structures. So we need to understand and follow the standard color code and symbols for lithological and structural units. And during traverse, all possible data are to be acquired in a systematic pattern. Different lithocontacts are to be traced and correlated, and after demarcation of lithology, structural data must be collected together during field traverses itself, and those are to be plotted in the map as per field notebook, where we have jotted down all the data. Here we often face few difficulties regarding the plotting of the data in the map, because there are numerous data like deep strike of bedding, cleavage and other types of foliation attitude, then joint, fault, folds, lineation, shear zone and associated structural fabric data. So point is that how to make all the structural symbol visible in a map in an unbiased way, because the symbol will itself occupy certain area, and as per the scale, that symbol size itself will be taking certain area. For example, in a map of 1:50,000 scale, 1 centimeter will be equal to 500 meter, and when we plot a particular symbol of deep strike, naturally in the map to be visible, that symbol has to be at least 1 centimeter in length or size. So that one single deep strike symbol itself will be representative of 500 meter at least. Try to understand that point. So that is only for structural deep strike data. What about other data of that same area? That is my point. So structural data plot need to follow the scale of map. And as I told, further detail, for example, in a 1:500 scale map, a small 10 meter by 10 meter outcrop itself may provide several data like joint, fall plane, orientation, foliation lineation, fold, shear zone data. Thus, it is not possible to make each of the symbol visible as per the scale. So in such map, a single deep strike symbol itself will occupy at least 1 centimeter length, as I told. So otherwise the symbol will not be visible. However, it is not proper representative of actual structure because it represents about 50 meter area for 1:5000 scale, as I told. Here in this figure also I will discuss in detail what are the issues. But to address the issues, we can imagine first a digital image which comprising several pixels. The smallest unit of a picture is called pixel. Therefore, we can imagine 1 centimeter by 1 centimeter pixels as unit area for average standardized data representation here. Similar like digital image. So that pixel means, for example, one particular symbol represents 50 meter by 50 meter area. So that symbol has to be plotted such a way, after averaging it out, it must represent 50 meter by 50 meter area. That is called 50 meter by 50 meter grid, for example, for time being. In field, we can consider all measurable representative data of 50 meter by 50 meter grid as per the scale, and then plot them in a rows diagram which give modal statistics. So as I told, structural data or any data plotting is not that much easy. Most of the times it is very much often neglected, and whatever data we are getting in a biased way we plot. Forget about scale. So the dominant direction from rows diagram can be considered as representative of that grid. There may be bimodal data as well. For example, as you can see this joint data plots in this representative rows diagram. Here also bimodal distribution you can see. Okay, so in this way all grid data may be plotted as per the location. In a precise normal distribution, naturally 68.27%, 95.45% and 99.73% of the data lie within 1, 2 and 3 standard deviations respectively of the mean. So this normal distribution representation also is shown in this figure. So therefore 3 sigma rule covers nearly all data within 3 standard deviation of the mean. Now within each grid 3 lines cover at least 33% data, as at the beginning I told what is the implication of 33%, because it is a subset and 1/3 of the population representation is good enough, and moreover it is not an entire population. One small pixel itself I am considered as population, mini population. So within that pixel 33% data will be covered by 3 lines automatically, as I have shown here. Okay, so this is 1/3 of actual and well representative of that particular pixel of that particular grid, that is 50 meter by 50 meter, for example in case of 1:5000 scale map. So in this pattern we can better represent the map and it will be very much accurate in irrespective of any time or any other geologist whoever will come into this area, they will also interpret and get accurate result. So that is called smart mapping, because it automatically takes care of representatives from different segments, that is 1 sigma, 2 sigma and 3 sigma sectors. Sigma is, of course, you must be knowing, that is standard deviation. So in case of structural data or any data plot in the map, statistics must be understood. Everywhere statistics is applicable. Therefore, considering 33% data to cover a broad representation of actual features, the data can be plotted in rows diagram first, which give the range and modes of data spread. From these, major trends can be considered for plotting in the map, considering to that particular corresponds to the particular grid. So this method can be applicable for all grids, and finally a clear-cut picture and representation of structural data can be imprinted in the map. Here a map is also shown as an example. Different litho units are observed to show joints, foliations and bedding data. In this map, a symbol, for example joint, covers 50 meter into 50 meter area. 50 meter by 50 meter area means one symbol. So one particular joint is representative of particular 50 meter by 50 meter area. And if we keep on collecting such data, naturally after plotting sector wise, it is cumbersome job, tedious job, but it will be perfect job. So therefore, for such 50 meter by 50 meter grid, all data are to be represented in a concise manner. Thus, rows diagram here is of optimum use, and it is used for choosing dominant orientation. And after having that, we can plot that on map. So in this way, each sector wise, small pixel or grid wise, we can plot one symbol, and it will be a perfect representation of the area in the map. Thank you.